Welcome. In today's tutorial, we are going to talk about image classification. It's the simplest image classification algorithm or a simple neural network architecture. It consists of 2 layers of the neural network, and we do it because the image dimension are 28 by 28 and one channel image, which is a gray channel image. So let's go and find it out. So let's see how the code works. So let's run it. You can have any image and any number from 0 to 9 on the image, and you can predict the number with this simple neural network. So let's try it. Here we choose 0. Image is 0, so the predicted number is 9, which is the model is wrong to predict the number. The next one is 7, so the predicted number is 7 is correct. And the next image is 4. Upload the image. The number is 4 and the predicted number is 4. The next one will be 2. Upload it. Predicted, so it's correct. As you can see, most of them are correct. So let's go and see how we can do this nice work with image classification with a simple neural network. Let's go and find it out. So this is the code for image classification. We use transforms, and the transforms comes from Torch Vision package or library. We download the dataset, training dataset in MNIST. We move it to data folder, and also we choose also test dataset, and we put it in data folder, and we use the transform here, and because we want to change the images to tensor, PyTorch tensor to train the model, and this function will make the pixels from 0 to 255 to 0 and 1, between the number between 0 and 1. So it will divide the pixels by 256. And then we use train loader with data loader to make the images in batches of 64 images in each batch for training. If you want to try to measure the image size, you can use uncomment these commands to see what is the image size and what is the label of the first image. For example, it can be from 0 to 9 with the image shown by 28 by 28 pixel, and then you can move it to NumPy. We can convert it to NumPy and transpose it to this tensor, because in CV2, which is the Python OpenCV, uses this dimension, this sequence of the channels, height, width, and channel, and you can uncomment these commands to see what is the image. And the neural network model has these 2 layers, and because it's 28 by 28, it will be around 100 pixels or nodes. I converted to 128 nodes or neurons, and then I apply a ReLU activation function, which introduces nonlinearity to the architecture of the neural network. Then I will use the nonlinear convolutional layer to convert the 128 neurons to 10 neurons, which are the number of the classes of the images. Since they are from 0 to 9, there will be 10 classes in the output. So we can check the result by getting the probability to each class, and we choose the highest probability that the model predicts to get the class number. For example, if the class, the fifth class, it has the highest probability, the number of the image will be 5. So for the model training, we use the cross entropy, which has also the error MSE and the softmax layer inside it to train the neural network. We use the Adam optimizer to update the weights, and we choose 10 epochs to train the model. And in this command, running loss put 0 at the beginning, and the correct number of the images will be 0 for the beginning, and the total numbers of the images will be 0 at the beginning. And we use this command to go into the image and labels of the batches for the training of each batch of the images, and we predict the image of the output of each batch. For example, if there are 64 images in each batch, here we will have 64 predictions, and output of the layers with the probability. And the loss, we will use the criterion, which is the cross entropy loss, with the true ground truth labels, and we use this 0 grad to initialize the optimizer and make it 0. And then we use this command loss backward to do the backward propagation. We use optimizer.step to update the weights. We use add the loss to the running loss for the batches for each batch, and then for each batch here we use the max to get the prediction class of the output. For example, if the highest probability for the first image in the batch is the 7th one, it will predict the 7 number for that image. And if the label is correct, it will add 1 here to the correct number of the images. So here it will be all the predicted labels of the batch, and if they are all correct, this number will be 64. And for the last batch, if it's also 64, which may not be 64, since the number of the images maybe is not multiplication of 64, so it can be, it might be lower than 64 images in the last batch. So we use this command to have the all correct images, and after each epoch we calculate the running loss for each batch, because here is the number of the total number of the batches, and then we calculate the accuracy with this command, since total is total number of the images that are predicted, and the correct is the total correct images that were predicted. And here we print it out on the screen to see how is the accuracy. And when the training is over, it will print training is complete. And then we save the model here, and then we print out that the model is saved. So let's run and see how it proceeds and prints the results. This is the code to make the connection with the backend, and the package that I'm using is Flask in Python, from the Python library. It's a Python library, and it will used for make an API to show the images on the web page, and also predict the images and show the result on the web page. And so this is the code. We use the Flask and Pillow, and we define again the model architecture is as the same as the model that we use for training the neural network. We use it again here. The last layer is 10 because it produces 10 classes for image output. And we define the uploaded folder to upload the images that the user select to the folder in the server, which is localhost here in my PC, to try if you are using in production, it will be a folder on the server. So next we will load the model, which the name is MNIST model, and it is the model that we created in the last step. The model is MNIST model, and then we use the transform package to convert the image that we are predicting to a grayscale channel, and then we resize it to 28 by 28, which can be compatible with our neural network that we have built. And then we convert it to tensor, PyTorch tensor, that makes it between the values between 0 and 1, and also it will be in PyTorch. As the next step, we will define an index function and index HTML page, and we put it in, make a templates folder in our root directory, and we define the index HTML file. And here is the HTML file. Here we define the normal code, and the title is image classification. Here we make a form to upload the image to the server, which is our local host here, and then it will show the uploaded image with this function here. And then we make the form to make a button to predict the number, connect to the backend to run the code to predict the number of the image on the image. And when you press the button predict the number, it will show it here in this section, predicted number, and the prediction that comes from the app file, which is the Python file that will be sent to the front end, which is this index HTML file. So let's go back and see the backend code for Flask. Here is the upload file function. We use post method to upload the files, and we render the index.html file, and then we predict the file with we open the image with pillow, and then we add the batch dimension, since the image will be height, width, and channel. We will use unsqueeze method to add the batch size at the beginning of the tensor. So we go further, and we use torch.nograd to predict the number on the image. We use the model to predict that, and we use torch.max to predict the class for the image, and then we use this command to get the prediction, and we move it to index.html file to show the result. And this function will display the uploaded image that we used here to upload the image. So it will display the image here, and when you run, it will run the code here. So let's try and find how it works. So this is going to take a little bit of time, so let's wait for a couple of seconds. Okay, so now it's ready on port 5000. It will be on localhost with the 5000 port, on 5000 port. So here will be select your image. I select my image. Here is the 01. Press the upload image to see the image, and then predict number, and so it will predict 9, which is not correct. So let's go and find out if it can predict the next image. Is the next one is the number 4, so predict the number, it's correct. And let's try with another image, 5, upload the image, 5, predicted number will be 5, it's correct. Number 6, upload the image, predict the number, it is correct. The next is 7, upload, so it's 7, predict the number, it's 7, 7 is correct. Next will be 2, upload the image, so predict the number, so it's correct. So the wrong one was this one, the 01. I made these numbers with the very simple paint program on the Windows. You can also make your own image number by making it black, the background black, and write the number with the white color, and then try out your own model to predict if it is correct or not. So thank you very much for watching this tutorial. I hope this tutorial helps you to understand the basic of the image classification. If you enjoy it, please like and share, and write any comment that you have in your mind. If you have any question about it, I will be very happy to answer your question. Thank you. See you next time. Bye.